Hello, everybody. Good morning. Welcome to Gecko, of course. This is a session about visual tests, snapshots. Let's get started. A bit about me. I'm Sendil. I'm originally from India. I'm a full stack engineer. You can tweet me at great. I've also released a couple of books. The recent one is about Rust and WebAssembly. It gives an hands-on experience with Rust and WebAssembly applications. The links are over there. Before that, I've also written a book on full stack development with Hipster. That's a bit about me. So let's start. Development is fun, right? It's all about fixing the problems and trying to invent a new solution around it. Generally, as humans, we are very happy to do this stuff, to invent a new thing and then fix our problems. But the other part of development is basically testing. And testing is kind of boring, right? Because in the world of testing, we are not being that much creative, and we are not building something awesome, but merely auditing the things that we have written already. We're just creating a stamp with which we can say like, oh, okay, this works. That's what we are doing with testing, right? But the other aspect of it, like it also takes a longer time to write tests. Like you can quickly stub out a feature and then release stuff, but the time and effort that it takes to write tests, it takes a longer time. And it's also additional work that you're doing for your application to work. But testing actually gives you the confidence to ship applications. So with a consistent and complete test suite, if you have, you can happily push the production button and then deploy to production without any worries. And thus testing will help us to automate the deployment and also have a very worry-free production rollout, right? And also testing helps you to capture the regression issues, thus preventing users, like when you add a new feature, this is very important for any product or application, right? So when you add a new feature, you have to give a consistent user experience for users. And with testing, you can actually do that. And another area is like testing also gives a better readability to code. Like, for example, if you have a weird if condition in the code, testing basically ensures that you're capturing that condition. And once you capture the condition, for anybody reading the code, they can just go ahead and verify the test case to find out why you have done that. And testing actually increases or enhances the developer experience.
Hey, can you? Oh yeah, thank you.
Cool. And yeah, so testing is essential for any development. And let's see how we can do that, how we can do the testing. On the other hand, so in the front-end world, right, so this is a React-based conference, so we're just talking about front-end world. There are hundreds and different types of testing, security testing, load testing, end-to-end testing, and there are a lot of this. But as for this one, we're just going to focus on three different things: unit testing, component testing, and visual testing. Again, unit testing, component testing is a subset of unit testing. Just popped it out a little bit so that we can deep dive into unit testing. That's it. So let's see the characteristics of different testings now. In case of number of tests that we are going to write for any application, the unit test is kind of like very higher in number. Like you're trying to write more and more unit tests because it's much more simpler to write and easier to execute. So you write more unit tests than compared with the component testing. But on the case of visual testing, you gradually tends to go much lower. Similarly, the time to write for a test, it's very low for unit testing, right? So you can stub out a unit test much faster because you're just testing a single functionality of your application. But component test, it kind of takes a little bit of time to write and set it up. Visual testing, on the other hand, takes enormous amount of time to set up and also to write. But all those testings gives you confidence to ship. But on the case of unit testing, the confidence to ship is much lower than compared with visual testing because we are actually verifying the visual elements. That gives a very good confidence for us to roll the application forward. It also gives the time to execute the test is also gradually increases when you go from unit testing to visual testing, because in visual testing, everything has to happen, screenshots to be taken, pictures to be compared. It takes a longer time to execute. And these are the things that we are seeing in the world of front-end testing, right? So let's start with the unit testing, the smaller component here. Let's start with the unit testing. Obviously, in a React application or in general any front-end system, the unit testing, we can split it into two varieties. One is the component testing. The other one is like util testing or the function testing, which is there. So it's very simple, right? The component testing is testing all the React or Vue or any component in your application, and the util testing is like and ensuring your functions work as and when it's required. So consider that we have a simple component like this, a component which is named as my component, and it just has 3 full components inside. So this is a basic component, right? This is a basic React component. If you want to do a component testing on this, we just have to test the functionality of this particular component. We just have to worry how this component is getting rendered on the screen. So in that scenario, what will happen over here is basically how we are going to write the test is basically as simple as this. This is a stubbed out simple test case. It just checks whether it renders 3 full components. That's basically what it's doing. So if you take a much closer look here, the first line of the test case itself is it tries to load the component. So we first set up the test case and then try to load the component. Here, the component is not loaded on any browser, right? It's just a render. It's done. Everything is happening on the render function, and everything the render outputs is captured as a string. And the next step, what we're trying to do is like manually validate the functionality of the component. So here we are validating that inside my component, I have 3 full components. That's what I'm trying to do. But what will happen if you change a component here? Change is pretty consistent, right? You have to go and do your components change a lot in the course of your development as well as after you release your product. So we will, of course, have to update the test once we update the component. And this will increase and add a lot of work in terms of test case maintenance. So the maintenance part of the test case where you have to go and change everything. Suppose you have hundreds of test cases that uses my component. You have hundreds of test cases. Each and every test case, you have to go and update when your component actually changes. So this will increase a lot of work for you. That's where snapshots came into the picture. So in case of snapshot testing, what we're doing is like we just test how the component renders. It works on the same principle where in your test case, you just load your component at first. Once you load the component, you match it with the snapshot object. That's basically it. So you're just going to check whether it matches an already existing string. So how does it work? Of course, you're going to run npm run test. It can be anything. It can be just, or it can be anywhere, any tool that you have. For the first time, it renders the component and then automatically creates a blob, text blob, right? It just contains a text blob. Consider it kind of a map. So the map has a key as a test case name and a value as the entire object that is rendered. It's text blob and just stick it. And then it creates a file called .snap. Inside where it puts everything inside. Then when you run your test again, it just matches with the snapshot file that it has created and then checks whether the test case generates the same output. That's what is happening. And when you have to update it, you need not go and change every single test case that you have written for it. What you can do is like you can just put a -u command. It just automatically updates a snapshot to the new value. And it's much more easier because everything is automated over here. So the advantage of snapshot testing is very simple. It's very easy to maintain the testing code because you don't have to update anything. It makes test consistent because you're not involving any browsers. It is magical, and it also enormously reduces the amount of time that you have to spend writing and updating tests because all you're going to do is just make the system work for you. And that's awesome. As developers, we tend to love that, right? Because we make the system work for us. Great, snapshot testing is all about greatness. Why can't we just do that? But the problem with the snapshot testings are it bloats the code base. This is approximated on a few open source projects that are using snapshots. As you can see here, the number of lines of code based on different projects, number of lines of code in the project, and see the number, 47% of those lines are for snapshot testing. These are like automatically generated content, and that lives on your code base, which is pretty annoying. It's making your code base huge. On the other hand, it also bloats the pull request up. Like if you're putting a pull request, if you're creating a diff or you're putting a merge request or anything, whatever way you call it, it adds the snapshots inside there, which kind of bloats a pull request. There are a lot of automatically generated content that lives, and it's very difficult for you to verify. For example, this code base just have like 2 or 3 lines of difference, 3 lines of code change, but that ends up in a huge bloated pull request, which has a lot of additions and deletions. And as developers, or as anybody, more the lines of code that you're reviewing, it kind of reduces and makes your code review much less effective. And that's a problem with snapshots because it loads your pull request. And also, it's very easy to lose context here because this is automatically generated content, which means it is very difficult for us to understand what is happening at some point of time. So few things that we have to do is like make the test names should be very explicit, like make sure that it's precise and does what it requires. Have some stricter rules when writing the test cases, and also stop blindly updating the snapshots because updating a snapshot or updating a test is much simpler. You just have to say -u, but you have to understand what is happening, what are the changes that goes into effect when you're doing that. So do not blindly update the snapshots. So as with many other things, especially in the software industry, especially in the development tools, there are awesome tools and that can be used pretty good. And you can use this development tools pretty nice. The snapshot testing also, you can use it better by following few of these things. One is like, do not try to overdo anything. Like for example, to not have snapshot testing everywhere. It's easy, but your util testing or the function that you're writing, do not go for snapshot testing. Go for unit testing. Go and do the unit testing there. And if your presentational components has a lot of logic inside it, then try to stay away from component testing. Try to stay away from like snapshot testing. Pull certain functionalities out and try to put that functionality in a separate util testing, and then try the other stuff like your component, which is just a presentational logic, put that inside the snapshot testing. And the obvious question everybody asks is like, why do we have to mount? Why do we have to shallow? When can we use those things together? The major difference is like shallow do not render a child of the component. So you have a component and you have multiple child inside. Shallow do not even try to render those components. So basically, shallow just does the constructor and render part of your component. On the other hand, mount actually renders a child, which means it's more resource intensive. It tries to render everything that an element has. And so if you are using mount, you can test the component.mount method or things like that when it happens after the mount has happened. So use them wisely, use them correctly. I've seen most of the places where people try to put mount in place of shallow and shallow in place of mount. So try to use them. So the problem with mount is like if you put a lot of mount, your snapshot is going to increase in the size, and which means like you obviously will lose what is happening inside the snapshot. So try to minimize that. And consider snapshot as a code, because whenever you're reviewing a code, make sure snapshots are given equal importance and consider them as a code. Even though it's auto-generated, these are pieces of code, try to consider that and try to review it more carefully. We have seen snapshots, because of snapshot updates, people do not tend to consider that as a code, and a lot of false code lives in false code or false spectrum. How do you say it? The false spectrum lives into the code, and the false conditions live in the code. So that is some problem. So try to consider snapshot as a code. And as with any test cases, in snapshot testing too, this has to have a single responsibility. Do not overload snapshot test because you're getting something for free, but try to always make sure all the test cases that you have inside snapshots are having single responsibility. And also the most important thing is like whenever you go for snapshot testing, sit back and have some time to understand how your components are getting beefed up with functionalities. And whenever there is a functionality beef up happening, try to revise and update test. So when you add more features into the component, when you try to add more things into the component, try to sit back and think like, can we move certain functions out of the component? Can I simplify the process that is happening over here? The more functions that you add into component, I think it's generally good to move away from snapshot and try to do the actual testing over there. Great. So unit testing is sharp out. The best thing is like it is faster and easier to write as well as to maintain the test cases. It takes very less time for things to run. And also it can run locally. You can test them locally, which is really nice. And you can set it up very fast and easy. You have a lot of places where you can check and how to do if you're stuck at some places. So this is really nice. So let's go to the second part of our stuff, which is visual testing. So in visual testing, it is as simple as that. You take screenshots of two different states of the application. You try to compare them. And if they match, you say yes. If they don't match, you say it's not matching. So let's see how visual testing works. So you go to a page. Practically, it can be any part of your application. It can be a local host or something. Wait, I'm telling you that you're going to a page. You're actually accessing something inside a browser, right? So what we can do with that? So yes, so we cannot go and rely on some unit testing tools here. We have to have someone that starts the browser engine and tries to run inside, tries to run the browser components inside, or tries to render the application inside. Here, we are not talking about programmatically creating a page content. We are talking about browsers trying to access and deliver content for us. So for that, we are using Puppeteer. Puppeteer helps you to it gives a high-level API control for running Chrome and Chromium-related stuff. It's not only Puppeteer, you have a lot of different tools for that. But for the purpose of this, let's think like we have something like Puppeteer that kind of helps you to run the application inside the browser. So the first and foremost thing in visual testing is basically you have to run your application inside a browser, right? And once you run the application, for example, in the React world, if you're using Just, you have some component, right? You have like Just Puppeteer library. You can just use it to gel Just and Puppeteer together to run them together. And you just have to set the preset as Just Puppeteer and then install the dependency. That's so simple, right? So once you do it, it looks like every other JavaScript test that you have. So basically, what you're doing is this is a simple test suite. The very first thing that you're trying to do is load the browser. You're creating a new browser instance. If it's not available already, it pops up a new browser. If it's available, it uses that. And then the new page actually opens a new tab for you. So your first step, you're loading a new tab inside there. And then you're going to that page. So basically, you're going to localhost 3000 and then wait till the network and all the connectivity ends there. So that's what you're trying to do. So you're going to a page. The next obvious step is you take a screenshot of the page. You take a screenshot saying okay, the page is loaded. I'm going to take a screenshot of the page. So that's what is happening here. You're taking a screenshot of the page. And once you take the screenshot of the page, you save that image with some name. So name usually will be the test case, followed by the file name followed by the test case name, and then .png or anything that is over there based on the tool that you're using. So you save that image. And once you saved it, you try to verify the image in the next stage. So first, if it's running for the first time, it just creates an image as with the snapshot testing. But if it's the second time that you're running and trying to verify it, what it does is it verifies the image, whether it's present is correct. So what we're trying to do is expect the screenshot that we took is actually matching the snapshot that we have took previously. So it goes ahead to the folder, checks two images, finds if they are matching. How do they do that? It's very simple. They use a library called Pixel Match. A few libraries use a few things different, but here a Pixel Match is more predominantly used. So what happens is for example, you have two images here, which shows a map of Zurich in Switzerland. And these two images slightly modified. So what you can see here, the third image, it actually does a pixel-to-pixel verification, and it shows us where are the pixels differ. The red areas are basically where are the pixels differ. So it does this. So it relies on the same principle. It has an image that is stored in your database, or sorry, in your file system, and then it takes a new screenshot and matches them pixel by pixel. If they match, it goes back and tells yeah, they're matching, no problem with that. If there is any pixel mismatches happening, it comes back and says to you, oh no, there is a pixel mismatch. Can you try to fix that? So that's how visual testing helps us. So visual testing basically gives a visual confirmation of what is happening and how it is happening. And it also increases the confidence of something that we are shipping, right? So you have visual confirmation of whatever is happening and how it is happening. So it increases the confidence in which you can ship the product. And as with the snapshot testing, visual testing is also magical because it automatically does everything for you. You're not going to take a screenshot. You're just going to say, take a screenshot and have it, and then verify it with my inline screenshot or verify it with my already existing screenshot. Those are two lines of code that is going to repeat everywhere. But underneath this, there's a lot of work that is happening. So it is kind of magical. And also it reduces time to write tests, I would say. Basically, it kind of reduces because you're just going to repeat these two lines and bulk of the work is done by the underlying library. But it's speculated. I would say it's arguable. You can disagree with me over there. But compared to normal way, if you're writing a screenshot test, but this way with Selenium and everything, compared to this way is much faster to write this and compared to the other ones. So that's great. Let's do visual testing, right? It seems super awesome. Why cannot we just go ahead and do that? The problem with visual testing or this, it bloats the code base again, similar to the snapshot testing, which bloats the code base based on the lines of code. Here, the code base is actually bloated by the size of the file that we're generating. As you can see here, for a small library, if you have like more than 100 to 200 components or more than 500 components, the problem is like the screenshots that you're going to have is going to be huge because every screenshot is an image of your application that is on a different state, and all those occupies the space in the memory. When your code base bloats in size, it finds it very difficult to handle. For you, it's also very, very difficult and annoying to handle because every command that you're going to run inside your terminal, like git refresh or git pull or git push, it's going to take a long time because it has to work on those megabytes and gigabytes of data that is there. So that is the major problem with visual testing. On an average, based on 7 open source projects again, it increases the build time in the CI more than 23% because here we are actually taking screenshots, matching 2 screenshots together. And this is taking a long time because it's image that we're talking about, pixel by pixel comparison, high resolution image equal to longer CI time. You can somehow hide them together, you can somehow reduce it, but again, at the end of the day, it takes a very long time in the CI. And that is also one of the major problems because in a fast-moving world, if you have to push certain things to production, if you're going to close your bug, it takes a longer time in the CI. So you have to worry about these things. And we are talking about screenshots, right? Screenshots are really, really the problematic stuff over here. Why? Basically, the screenshot actually depends on a few things. It is based on the operating system. It is based on the browser and also aspect ratio. The libraries are much evolved. You have some way in which you can control the aspect ratio. You can reduce the amount of aspect, reduce the size of the application that you're loading, and then you can make sure that everything is perfect, stretched out and everything. But rendering is based on operating system and browser. And it differs a lot of things. Like, for example, font rendering is completely different in how Linux works and how Windows work and how Mac works. And these are the things that you have to understand. As a developer who's just writing a web application, we might not have dwelled into the topic of like how this rendering works inside for the font and everything. But you have to understand how this works and logically have a mechanism to fix it. And that's the problem. What kind of fixes that we can think of? Of course, when we talk about multiple different operating systems, the common trend line solution is Docker image. Have a Docker image in which your application is going to run, take screenshots, and then do that. And then do the check. And then you can run actually the CI on different operating systems because as a product, as a web application, of course, there will be multiple different people who are going to run your application on different operating systems, on different browsers, try to emulate those scenarios and try to put CI for those things. Mind the fact that when you're adding different operating system and different browsers, you're actually increasing the CI time and try to reduce the CI time there. Like try to take a judgeful call on that. Like for example, if your application's major user is Chrome, try to stick with only Chrome on Windows or on Linux or Mac OS based on your market share and things like that. Think in that way because increase in time of CI based on different operating systems that we have will also increase terribly across multiple places. And the other thing is like fixing the image size. Like if you're working at like some pixel size or some size of your application, try to fix that as an image size. Try to fix the width and height of the applications together. And it kind of helps you to ensure whatever you're developing, whatever the screenshot that you're taking, actually matches everything together. The next problem is basically maintaining the state of the page. So when taking screenshot, of course, the components have state with it. Are you going to take the empty state? Or are you going to take the state that is filled with everything? How do you take the screenshot? What are the things that you have to take into consideration over there? This is the most essential part of it. Like there are multiple ways in which you can solve this problem, but this is a huge problem because The moment you add a lot of states in your component, the moment you have a lot of states or have the lot of states in the component, the number of test cases that you have to check for visual elements or visual differences is going to be increasing. And it's a matrix increase, right? So you increase at one place, other thing also gets increased. So you have to consistently worry about those things. Like, how do you find out what are the different states that you have and what are the different states that you're going to test? So few fixes on the majority of this thing is like Storybook. Storybook really helps you a lot over here. What you can do is like you can create a storybook, and in the storybook you can have the components, you can have different pages with different states and with everything that is required. But you literally generating a static page with all your components and their properties or states. And once you have that, use that entire storybook as a source of your visual testing. So try to create visual tests for each and every thing that you have, every page that you're going to have on the sidebar. Create a storybook based visual testing. So what you're trying to do is like in the storybook, you're trying to align everything. You're trying to create all the components. You're going to put different states and then try to show users how the component will behave in different state when you give different state input to it. You're going to generically have this. This is a static page. Try to generate visual images for each of the static content over there. Try to remove all the components outside and just try to take your component and then show it to the user. And then do your visual difference testing on top of it, which really helps you to do it. And also one of the main things is like you can mock the responses in the storybook, right? So mock the responses from your data point and then try to generate a storybook out of it. Use that storybook as a source of visual testing. It kind of helps you to overcome this most complex thing that is the page state and how we are going to handle it. The next problem is basically updating the screenshot is very tedious and it's time consuming. Updating a screenshot is as simple as snapshot of Z, which is like -u. But the problem with that is like whenever you try to update a screenshot, the generic problem here comes as like basically you're trying to go delete the image that is already there. You're trying to put a new image over there, and then try to run everything inside a Docker environment, and then pull all the changes, put it outside of the system, and then put it over there. That sounds complex, even when I'm talking about it. And it's a huge process that's going to happen, and it's very time consuming for you to do. So it's usually better if you have some finished components, right? If the component is done, it's ready for production, it's going to deploy. Try to introduce screenshot testing only when it's about to release the new feature. So when you're going to release the particular component. If the component is heavily under development, do not even think about screenshot testing, because every time you're going to update the screenshots, which will take a longer time to do it. And that is the biggest problem that you're going to have. So always try to find a perfect sync there, because the update part is long. So try to reduce that by doing screenshot testing only for the features that you released or that you're going to release, and it's almost on the final state of changes. And other things that you have to worry about in terms of screenshot testing is basically you have to make sure the screenshot lives in the same repo. It's kind of a unit test, right? It is kind of a unit test. You can put that in the same repo and make sure the repo is smaller. When you see the screenshots are actually taking more size, I would argue like if it's like more than 30% of the total files that you have, if it's more than that, try to remove the screenshots away and then put in a separate repo or separate system and use that automatically. Put in something in a remote environment like an S3 or something like that. Because when you do that, you're actually reducing the problem with the developers, because the developers, when you're writing the code, when you're committing the code, the screenshots will not be a problem to you. It will kind of helps you to achieve something faster. And so the main thing that I'm trying to tell you here is like, always have your code repo smaller. Whenever you feel screenshots is occupying more size, push that into remote. Put it somewhere else and check it from there. Of course, it's going to increase the CI time. Make CI so optional. The screenshot testing of CI optional if you want to, if it takes very long for you to test everything. But ensure that it lives outside such that the developers will not have to worry about the size of the application that you're going to commit and things like that. And the most important thing, the most annoying thing in screenshot testing is basically all the good things that you've done in a web application. So in a web application, handling animations or blinking cursor, spinners, progress bar, all those things that has a motion into it, that has a small sort of animation that gives life to the application, or the things that annoys or wrecks your snapshot, so screenshot testing or visual testing. So what you can do is like you can wait for these things to complete. This is very important. You can wait for these things to complete, or just shut it off. Put a small CSS that kind of closes out all the transactions or the transitions, all the animations that is happening in a web page that you're loading, and then use that small chunk. So it's very important that you're removing them out. But when you remove them, you actually have a static page and then cross-verify the screenshots. So that is something that you can take into consideration. So as a whole, so far what I've seen is snapshot testing, unit testing, and visual testing. Use the snapshot testing for the presentational components. Try to remove logics inside it. Keep it very simple. Use proper name for test and treat them as a code. Treat the snapshot as a code. Unit testing, use it for components with logic. When you have a lot of logic stuffed into a component, don't go for snapshots. Try to go for the component part of testing. And use proper name for test, of course, that is there. And when you're doing visual testing, it's very important. Use it for only the user-facing UI that you have. Use it only for those critical production-ready stuffs that you want to do with. Test them for various form factor, devices, operating system. Use a separate repo for keeping your images if you require it. And run and test them as a part of deployment process. This is very essential. But sometimes when your CI takes a longer time to do and you want to push things faster to production, it's okay to skip this test, but it's very essential to have it as a part of your deployment process. Right. And the other thing is like when we talk about testing, everybody comes and says, oh, I want 100% testing everywhere. I want to do 100% testing everywhere. So 100% testing is enough. Don't go for 100% testing. Try to ensure that all the functionalities that you have is covered. Try to make sure that everything that your customers and everything that you're building, all the business critical part of it, has been tested and covered with this. Do not try to overdo everything. Do not try to do like 100% of test coverage if you really don't want to do that. And the other thing is like instead of 100% testing, what you can do is like use things like linters and types effectively. So in types, you can actually try to fix certain problems that is going to happen. Like for example, some null or undefined cases that you want to handle it. You can use types effectively. Make sure that you're not putting question mark in your types, which actually solves a lot of problem for you. And linters or basically helps you like next time there is a code style issue in your diff or pull request, make sure that you have linters for them rather than like saying the developer, oh, you missed a space or you missed an empty line, put a linter for that and try to do everything programmatically over there rather than like coming back and doing certain things. Linters and types effectively reduces the amount of test cases that you have to write. You can do that effectively with those two things. And always remember, tests should increase the confidence of your release. Like whenever you're going to release something, testing should actually increase the confidence that you're releasing and ensure things are working. So that is the primary purpose of testing. And it should not be a burden for developers. Nobody should come back and say like, oh, it's boring to write a test because they're essential part of the development, but you have to keep them minimal. Try to ensure that everything is covered inside test rather than like covering everything in tests. And finally, do not over-engineer things and overuse the tools. Use them wisely and for what it has been created, and try to go and stick in the direction of what you're doing it. And that's basically it. Any questions you can ask me over here, or also you can also reach me at my Twitter handle. Thanks. Hey, Anna and Tanai, do you have any questions?
Testing in React. So, like my question for you is the very first question is these days, especially these days, I'm seeing a lot of startups. Even I'm working with a Y Combinator startup in Bangalore, India. What I'm seeing there is they're not putting that much of emphasis on testing, right? What they do is they have a development mode and they have a production mode, especially in the startups where the things have to be very fast, right? You need to send the code really fast. So basically, what I see there is that they are not putting so much of emphasis on test. They do a testing in a development mode app, and then they push the code to the production. So that's what I'm seeing. So any comments on that? Like, do you find it a good way of coding, a good way of development? And if you don't find it a good way, like what could be a good way, better way to do that? Especially in a very fast moving startup where things are changing in a very fast pace. Maybe like a e-commerce startup or something. Yeah.
Yeah, I mean, like one of the major thing that I consider is like even in startups, when I was working for a startup and things like that, it's like everything was like fast moving, and then people wanted to move forward, and they kind of take test cases as like a burden or something. Like they want this thing to be an external thing that they want to do it just to release it and things like that. But you can actually streamline this process, like trying to factor out what are the major features that you want to do, what are the major features that is going to end up in the system, and you can have a test coverage for them. And I see a lot of places where people try to over-engineer certain things, and that's basically my slide. Is like, do not try to over-engineer or overuse a certain tool. Try to use them wisely and try to have like if you're releasing if you're a startup, all you're gonna do is like you are gonna have like for example, you are gonna have 5 different features for your customers, right? Ensure that whatever you're building, those 5 features that is going to end up in the customers have completely discovered and have all those confidence meters built up. But if you have like 2 or 3 features that is in the process of working, you can slightly have try to release them by having some testing and things like that. But at the end of the day, when it goes to customer, when you're releasing it out like at least 1 to 10% of the customers, then try to put that fixing over there. There are some cases where you want to do A/B testing. That's perfectly fine. You can do A/B testing and things like that. But on the other hand, it's better to have like completely tested product that is going out to the customers. And if it's a minor internal feature, minor feature upgrade, it's better to have it separate. Yeah. Does that answer your question?
Yeah, definitely. Thanks, Adin. So they have their own way basically
Yeah.
do the testing and to deal with things like that. So I'm just waiting for more questions to come from the audience. Side. Yeah. So okay, so I have a question here. There is a current discussion about enzyme React testing library here in the chat. What are your thoughts on that?
Okay, that's a good question. I would say I'm not gonna say like Enzyme is better or React testing library is better. Use them both. I would say Enzyme is actually beta tested a lot because it has a lot of cool stuff that was there, and I have worked a lot on Enzyme, and it has everything that I require. Maybe in React 17, when the new feature is released, React testing library has slightly higher features than compared with Enzyme, but they're catching up. So if you're in a traditional code base, if you have like long time React application doing a lot of React stuff, I would say like stick with Enzyme because it has everything over there. But on the other hand, React testing library also has a lot of features, but it's also relatively new. Yeah. Use whatever you have and you're comfortable with. That's my thought.
Yeah. So I hope that answers the question. Sandal, again, thank you for the amazing session. Guys, you can connect with Sandal on LinkedIn and on other social media handles. So, yeah.
Thanks, folks.
Thanks.
Bye.
Thank you.